In the previous video, we saw a couple of ideas. First is the fact that parallel vectors can be added really easily. Second is that we can break down two given vectors into x and y components, combine the x components because they are parallel, and combine the y components because they are parallel. So now our final goal is how to put this together to get the sum. So we call this recombining vector. So we have Rx, Ry from the given vectors A and B. Our goal is to find R, which is A plus B. When we say find R, it means we want to find its magnitude and its direction. How to combine them? Recall that the x component and y component of a vector R add up to R because Rx plus Ry equals R. So based on the diagram, that's Rx, Ry, and this is R. But what you notice here is that this is a right triangle, which means we can use the find the hypotenuse by the Pythagoras theorem. That's the magnitude of R, which is the hypotenuse. So that's going to be square root of Rx squared plus Ry squared. But then also from trigonometry, we know that tangent is opposite over adjacent. So tan theta R is Ry over Rx, or theta R becomes tan inverse of Ry over Rx. Right, so in the previous example, the Rx was let's say we end up with Rx is 7.45 and Ry is 3.20. This is not the number from the previous example. I'm just picking some random numbers here. You can find the magnitude of the vector as square root of 7.45 squared plus 3.20 squared. This is pretty much similar to the calculations that you've done before for Pythagoras theorem. So this should not be anything new. Just plugging this into the calculator and it gives me 8.11. So that's going to be the magnitude. And then the direction is going to be inverse tan of 3.20 over 7.45. Inverse tan of 3.20, 7.45, which is 23.24 degrees, which works out fine because if my Rx and Ry are both positive, that means I'm in quadrant 1. And if I'm in quadrant 1, then this angle being 23.24 degrees makes sense. So you will have to verify that the angle is correct and it's in the correct quadrant for the vector. So an example, a motorboat travels 7 kilometers an hour in still water. So see, there's a stream, there's a boat. It can travel 7 kilometers an hour across a stream that flows to the left at 3.20 kilometers per hour. What is the resulting velocity of the boat? Now, from experience, you know that if you have a current to the left and you go directly across, you're going to end up somewhere here, which makes sense here when you draw the diagram. So let's change this into an axis. So we have a vector that's 7 and it's going along the y-axis, and we have a vector here which is 3.20. Now what's the angle of this vector? That's 90 degrees, and this is 180 degrees. So what we have is a vector A whose magnitude is 7 and whose direction is 90, and we have a vector B whose magnitude is 3.2 and whose direction is 180. So first I find Rx, which is going to be Ax plus Bx. That's 7 cosine 90 plus 3.2 cosine 180. So this comes out to negative 3.2. And Ry is Ay plus By, which comes out to 7 sine 90 plus 3.2 sine 180, which is 7. Now just based on this, we know that the Rx, or the vector, is in the second quadrant. Now the angle is going to be tan inverse of Ry over Rx, which is inverse tan of 7 over negative 3.2 Tan inverse of 7 divided by negative 3.2 comes out to negative 65.43 degrees. Now, this doesn't make sense because it has to be in quadrant 2, so you have to convert this to quadrant 2. Now, this is using the reference angle from trig that we did. Negative 65.43 means this is 65.43. To make it into a quadrant 2 angle, we extend it, and this is 65.43. Then we can find this. The required angle is 180 minus 65.43, which is 180 minus 65.43, which is 114.57 degrees. So what we have is that the resultant velocity is square root of rx squared plus ry squared, which is 3.2 squared plus 7 squared is about 7.7 kilometers per hour, and the direction is 114.57 degrees. Now remember, although this is negative, when you square it, it's going to be positive. So be careful about that. So that's it for addition